So one thing to remember is that the amounts of material involved are pretty small. So this is a glass ball that is the same size as the plutonium for the Nagasaki bomb. So you need more. As I mentioned, the gun-type bomb is much less efficient. So you would need sort of two 2-liter bottles of HEU for the gun-type bomb. But it's still not a huge amount of material that we're talking about. And what's more, although it is radioactive, it's not especially radioactive. And it's unfortunately not especially difficult to carry around, smuggle, etc. It's very difficult to find. This is a guy by the name of Sergeant Herb Blair. And in this, you can see he's just got no special equipment. He's wearing a T-shirt and very dirty chinos. And in this box, he's got the plutonium for the first ever nuclear bomb, for the Trinity test, that he's carrying in one hand. Okay? So stopping nuclear smuggling once stuff is out of the place where it's supposed to be is a very difficult problem. All right, so some terms you'll often hear, but which are misleading about nuclear materials. One of them, so highly enriched uranium, what is highly enriched uranium? It's defined as uranium that contains at least 20% U-235. It's a somewhat arbitrary definition. In principle, you can make a bomb with slightly less enriched material than 20%, but the amount you need goes up and up and up, and it's really not practical to make a bomb with anything less than 20% material. People often refer to weapons-grade uranium as being uranium with 90% or more U-235. Sometimes you'll see 93% or more U-235. That's sort of a U.S. definition, because that's what we enriched all our stuff to 93%. But you can make bombs with material far below weapon grade, and as I mentioned, the Hiroshima bomb was not weapon grade material.
And do you know what the lowest enrichment level for working bombs that's ever been tested?
A, I don't. B, if I did, it would probably be classified. Plutonium, weapons grade is defined as 90% or more. Plutonium-239. Actually, again, 93% is often often used as the definition, as opposed to reactor-grade plutonium, where if you want to operate one of these power reactors efficiently, you don't want to keep pulling the material out as soon as some plutonium is built up. So you leave it in for a long time, and that means more of this plutonium-240 builds up from absorption of neutrons in the plutonium-239. And weapons makers prefer weapons-grade plutonium because there's not so much of this plutonium-240 around, and also some of the other annoying isotopes. But you can make a bomb with reactor-grade plutonium. With reactor-grade plutonium, you have, which has more plutonium-240 and so on, you have a higher neutron emission rate. So that means that there's a higher chance that a neutron will happen at the wrong time and set the chain reaction off before you want it to be set off. But the fizzle yield, that is the yield you would get if a neutron happened at the worst possible time for the Nagasaki design, is about a kiloton. And the destruct radius for a kiloton is about a third of the destruct radius of the Hiroshima bomb. So we're still talking about something that would ruin your whole day. It's much lower yield, but and there are some advanced designs that are what are called pre-initiation proof. No matter how many neutrons you have, it won't go off prematurely. You also have higher heat emission, which is more difficult, I would argue, to deal with. There are various ways you can deal with that. There's higher radiation, so you need more shielding when you're fabricating the weapon parts and things like that. So reactor-grade plutonium is not going to be the preferred material, but it is a usable material either at the crude level or at the sophisticated level.
How do you enrich to weapons-grade plutonium from reactor-grade? I mean, reactor-grade is what you chemically separate from
No. So what you try to do usually is just produce it as weapon-grade in the first place. So you have a reactor that, instead of being primarily designed to produce power, is primarily designed to produce plutonium, and you some plutonium-239 builds up, and some plutonium-240 builds up, but only a little, and then you pull the stuff out before more plutonium-240 builds up. Whereas if you're running a power reactor, you don't want to be pulling the stuff out all the time. You want to run it for 9 months or a year or something before you pull out fuel, and as a result, a huge amount of plutonium-240 builds up. So you might have 20-30% plutonium-240 in power reactor plutonium, and you might have 5-7% in plutonium-240 in weapon, plutonium produced for a weapon purpose.